Hi everyone, this is Vernon Martin from your Philosophy 4 Introduction to Critical Thinking course. In this video tutorial, we're going to be talking about truth functional argument, and in particular, we're going to discuss the conditional claim. The conditional claim and truth functional arguments can present some students with a considerable amount of difficulty in understanding what the conditional sentence logically implies and what it doesn't imply. Perhaps the simplicity of the language involved is what tends to obscure the logical implications of conditional claims, but regardless, this video is to help you get a better handle on the conditional claim as it applies to truth functional arguments. So, when we talk about conditional claims, we're talking about a claim that is of the form if P then Q. This is just the basic symbolized form to stand for a if then claim. These conditional claims show up all the time in ordinary language, but the logical implication of what's entailed when we use this is kind of tricky to get a handle on in some contexts. For this context, I'm going to use the example of clouds and rain. So for P is going to stand for it is raining, and our Q term is going to stand for there are clouds. So in using P and Q to stand for those simple claims, this sentence would say, if it is raining, then there are clouds. The symbol for the conditional is the sideways horseshoe. What's entailed in the symbol are the words if, then. The if then are not part of each of these simple claims. The conditional then is a complex statement. It's a complex truth functional statement. And so if you were to read this, you'd be saying if P then Q, or if it is raining, then there are clouds. The conditional claim is a statement that holds a special logical relationship. So though we are using statements like this that seem to correspond to facts about the weather concerning the conditions for rain, the logic of the conditional claim itself isn't a matter of facts about the weather or any such thing. So in our example here, the simple claim that it is raining, which is represented by our P term, is known as the antecedent and the sufficient condition of the conditional. It is the position of the term here in the antecedent position that establishes it as having that relationship in the conditional as the sufficient condition. So what we mean by sufficient condition here is that it's enough to know that if it is raining, that is, it is raining is true, that we can also know that it's true that there are clouds. Here, that there are clouds refers to the consequent of the conditional and the necessary condition. So while the terminology here might seem a little confusing, it actually makes sense here. It must be the case that there are clouds for it to be the case that it is raining. So that must here refers to the necessary condition. Now, again, what's important to remember is that the necessary condition is established by the position of that term in the whole conditional. So, if we had a conditional that said, if Q, then P, Q would then refer to the sufficient condition, and P would refer to the necessary condition. Even though that would completely betray our knowledge of how rain works and how clouds are necessary for there to be rain. So what I'm trying to point out here is that it's the position that indicates the logical relationship of this complex claim that is of the conditional, the relationship between these two terms, and whether one is an antecedent or one is a consequent. That is established by the meaning, the logical meaning, and then the claim itself attempts to represent that meaning by establishing the relationship of the antecedent with the consequent. In our last slide here, I want to discuss the truth value of the conditional claim itself. That is, when is the conditional, the whole conditional claim, if it is raining then there are clouds, when is that claim true and when is it false? So the way I'm going to do this is I'm going to establish a truth table for this conditional claim. This will hold true for any conditional claim of the form if P then Q. On the left here, I'm simply representing all the possible truth value combinations for P and Q, such that this row, I'm establishing the truth value of this whole conditional here based on the truth value of P being true and Q being true. In row 2, P is true, Q is false, and so on. I think the best way to understand how you get the truth value of a conditional is to think about that conditional as a type of a promise. If the promise is that when it's true that it's raining, it's true that there are clouds, the only time that that conditional is false is when it's true that it's raining and it's false that there are clouds. It's a type of promise. I say, if it's raining, there's clouds. Well, that promise, if we thought about it that way, would be broken when it is raining but there aren't any clouds. And that particular combination of truth values happens here, where it's true that it's raining and it's false that there are clouds. That makes the entire conditional claim, the whole thing, because we're putting it under the main operator, false. When the conditional is false, we've broken the promise. Consider that when you're working through those logic puzzles about frogs and snakes, about if there's an odd number on one side, there has to be a vowel on the other. And so in all other cases, when P is true and Q is true, that whole claim, the whole conditional claim, is also true. That makes sense. It corresponds to exactly what I'm saying in the conditional. If it's true that it's raining, it's true that there are clouds. Row 3 is a little bit tricky. It's false that it's raining, and it's true that there are clouds. Well, that happens all the time. It's just a cloudy day. It doesn't break the promise. There's nothing, the promise isn't broken. The promise is only broken when it's raining and there are no clouds, or it's raining and it's false that there are clouds. And so row 4, it's false that it's raining, it's false that there are clouds. The conditional still hasn't been broken. So this is the corresponding truth values for that conditional claim. Now remember, this holds true no matter what Q is, no matter what P is. In other words, this whole conditional doesn't hold true only when we're talking about P standing for it is raining and Q standing for there are clouds. That's the nature of logic. The logic condition refers to the form. If you're thinking that the P here refers to the content of it's raining and the Q standing for the content of there are clouds, and that's what's holding this logical relationship together, you're wrong. What's holding this logical relationship together of the conditional is the placement of the terms, of what's in the antecedent and what's in the consequent position. And this whole truth table applies for any conditional claim where P stands for the antecedent and Q stands for the consequent. Okay, I hope that helps you get a better handle on what we're talking about here in terms of this relationship, this logical relationship that's entailed in conditional claims.